Today we have a 79cc Predator. We're going to tear this motor down, pull the governor out, and we're going to install a billet flywheel. This is a prototype, however, by the time you watch this video, they should be available for purchase. So let's take this engine apart and get it down to where we can see the governor. Now here's the governor arm on top. You just loosen that nut, spread this open here, and then you can pull the arm right off the shaft. With the governor arm removed, we're gonna take the blower housing off, which is gonna give us access to the flywheel. Use a 17mm socket and an impact gun to remove that flywheel nut. What we do here is we put a little plumber's tape on the threads of the crankshaft, and then we take our flywheel nut and we thread it on backwards, and we thread it on until it's flush with the end of the crankshaft, because what we're going to do here is smack that with a hammer, and we're trying to protect the threads on the crankshaft so we don't ruin them. We use a big screwdriver, wedge it between the flywheel and the block, and we give it a nice solid smack right there on the flywheel nut. This will break the flywheel off its taper without using a puller, which for some reason is not recommended. So we can take the flywheel nut off and pull our flywheel off of there. The next thing we're going to do is tap the flywheel key out of the crankshaft. We're using a punch and then a little hammer, and being careful not to accidentally mar the taper on the crankshaft. So we just tap the flywheel key out of there, pull it out of the crankshaft. Otherwise we won't be able to pull the crank out of the block. The key will hit the bearing. So we take the spark plug out of the engine, and we take the valve cover off, save our gasket, and then we move on to the side cover. There's always a little bit of oil in these engines. They get test started at the factory, and then we try to be careful to save the gasket. A lot of times the gasket, part of it's going to want to stay with the side cover, and part of it's going to want to stay with the engine. And sometimes the camshaft will come out with the side cover like that. No big deal. If it comes out with the side cover, just hang on to it. And now we're pulling the lifters out. Sometimes those will fall out into the engine block. Not a big deal, just take those out. And here we have the push rods, and sometimes those will fall down into the block, and again, not a big deal. Here we're removing a mysterious substance from the block and realizing we should probably be wearing gloves. But there's the governor gear back there. We're going to get to that. First we're going to loosen up the connecting rod bolts. Number 10 wrench, stick it on there. We use the crank as leverage, doing this with one hand. We loosen those up a little at a time until we can unthread those bolts and remove the end cap from the connecting rod. Now you might be wondering if all this is really necessary to get the governor out of the engine, and I would say yes, it's necessary. We basically need to tear the engine completely down in order to access the governor gear and do what we need to do to get rid of the governor. You could always bypass the governor, and you could do that externally without opening the engine up, but then you're leaving the governor parts inside the engine, which could potentially come apart inside and destroy your engine. So yes, we tear the engine completely down. We did try to leave the cylinder head on and see if we can get the governor out without removing the cylinder head and leaving the rod and piston inside the engine, but we couldn't really get the clearance that we needed to pull everything out. So here we're moving on to the cylinder head and taking that off, which is what we normally would do anyway. But for the sake of saving time, we decided we'd see if we could go without removing the cylinder head. So be careful when you take the cylinder head off. There's two guide pins, and we have one here that stayed in the block, and we have one there that came out with the cylinder head. You just don't want to lose track of those. With the cylinder head off and out of the way, we now have access to our piston. So we're going to reach inside and grab the connecting rod and push the two up out of the bore. With the rod and piston out, now we can pull our crankshaft out of our engine. So our block is pretty bare now. You can still see the governor gear in there with the little governor lever. We pull this pin off the top of the lever, and that allows us to pull the lever out of the bottom of the block. With the crank in the block, you're gonna have a hard time getting that lever out. And so here you can see something very important. 9 times out of 10, that washer stays stuck to the top of the block. And that's something that you don't want to leave inside the engine block. Make sure you get that washer out of the block. And next up, we're going to take a punch and a hammer, and we're going to knock this pin out of the block that the governor gear is on. Real easy to knock that out of there, and that takes the whole gear assembly out of the engine block. And another important thing here, there's another washer behind that governor gear, and again, 9 times out of 10, that thing stays stuck inside the engine block. So make sure you grab that. So with the 2 washers out of there, we have 2 governor holes in the block now that need to be plugged up. So we're going to focus on the top governor hole. We thread these with the 1/4 tap so that we can plug them with a 1/4 bolt. So we get this first hole threaded. That one's easy. And now we can get our 1/4 bolt in there. But we're going to grab our crankshaft here, and we're going to take off that governor gear. That gear ran the governor, and we no longer need it on the crankshaft. It's just extra rotating mass on the crank. So we take our punch and a hammer, and we just tap that gear off of our crankshaft. Now we're doing a quick mock-up here to show you why the next step is necessary. On that second governor hole in the engine block that we need to plug up, you can see that nipple that comes out of the block. It makes contact with our flywheel. So we're going to have to cut that off of the block so that we can put a bolt in there, and it's all going to clear the flywheel. Now we talked to ARC about this, and they said that they put epoxy in the hole. And I guess that's their resolution for this, but I don't know. In our mock-up, it looks like even if you put epoxy in the hole, it looks like the flywheel still wants to make contact with that area, that little nipple that's sticking up out of the block there. So we go ahead and just cut it off. And if we make our billet flywheel with adjustable timing that we've been using, if we make that available, it's going to be the same process. Our adjustable flywheel makes contact in the same spot, and so we're having to cut that nipple off, and then we thread it 1/4 so we can run a bolt in there, and that's how we get the clearance that we need for the flywheel. These bolts that we're putting into the governor holes, they never need to come out. So we put a generous amount of Loctite on the bolts, and that also helps seal the hole so we don't get any oil coming out of those holes. Once that Loctite is dried up in there, it creates a pretty good seal, and we never have any issues with oil coming out of those holes. Once we have the bolts in the 2 governor holes, the governor removal is complete, and then we move on to assembly. Here we have the crankshaft in the engine, and we're just lubricating the crank journal. Next up, we're going to put the piston and rod assembly inside our engine. We like to lube everything up so that nothing's dry going into this engine. Here we're clocking the end gap on our rings. We want to make sure that the open gap on the rings are 180 degrees from each other and not lined up with each other. We use a little bit of pressure with one hand on the top of the piston, and then we use a popsicle stick to carefully push the rings into the bore. We find that it's easiest to start where the gap is on the rings. Push that part in first, and then work your way around the ring as you put gentle pressure on top of the piston. And you have to look inside and make sure that your connecting rod is lined up with the crank journal. So just work your way around, and ring by ring the piston will pop inside the bore. Don't be in a rush here. If you're in a rush and you're getting out a hammer and you're trying to hammer that piston in, you run the risk of breaking a ring, and then you go through all this work for nothing really, because you'll have to tear the engine apart to fix that later. Now we're grabbing our connecting rod end cap, putting a little lubricant on there, and getting that bolted up inside our engine. A little bit of oil on the rod bolts, and we get those threaded in hand tight first. Now we torque those connecting rod bolts to 144 inch-pounds. We'll give you guys some torque specs on some other bolts as well, and these torque specs came to us from Harbor Freight. We have an email from 2010 where we emailed tech support asking for some information such as torque specs. So 144 inch-pounds on the connecting rod bolts. Now we have our cam. We're going to put a little bit of oil on our cam and get that installed. Most people know by now, if you're watching this video, that there are timing marks on the cam gear and on the crank gear, and you want to make sure that you line up those marks. So the bottom end is pretty much buttoned up here. We're putting the dowel pins in the block and a new gasket. We weren't able to save the original gasket. We had to scrape that off. Little more lube on the metal to metal areas, and then we slide on our side cover, making sure that snaps in place over our dowel pins. And then the side cover bolts, we torque those down to 96 inch-pounds. So now we have the bottom end of our engine buttoned up. It's time to move on to the top end and put the cylinder head on. And so obviously, if you're going to go through all this work to remove the governor, this is a great time to install some performance parts. If you want a custom ground cam, this would be a great time to do that. Any cylinder head work, porting, milling, this would be a great time to have that stuff done. And so we put our cylinder head back on. We use the stock gasket, the dowel pins, get the cylinder head on, put our bolts in, and then we torque the cylinder head bolts to 22 foot-pounds. Now here's a piston dead stop. We're going to put the flywheel on next, but first we thread in this piston dead stop. And this is going to allow us to torque down the flywheel nut without the crank turning. We're gently tapping in our flywheel key back into the crankshaft. And finally, it's time to install the beautiful billet flywheel. We get it on the taper and we line up the flywheel key, make sure that's in the appropriate spot on the flywheel. Now we rotate the flywheel and the crank until the piston comes up and makes contact with the dead stop, and that's going to allow us to torque down that flywheel nut without the crank turning. And here you can see we have the adequate clearance that we need from the bolt that we used to plug up the governor hole. Next we need to move on to the coil, and so this prototype flywheel was sent to us with 2 bolts and 2 spacers, and so we use those bolts and those spacers here on the coil, because without the spacers the coil didn't line up with the magnet on the flywheel. It was offset, and so we had to put the spacers behind the coil to space the coil out from the block a little bit in order for the coil legs to line up with the magnet on the flywheel. And once you do that and space the coil out, you also have to space out the blower housing from the block as well. Otherwise the blower housing will hit the coil. So anyway, here we're setting the air gap. We're setting the air gap to 30 thousandths, checking with the feeler gauge, and then torquing down those 2 bolts. And there you can see the spacers, and you can see we have good alignment with the legs of our coil on the magnet of the flywheel. These are the 2 aluminum spacers supplied by ARC, and when we talked to them about this and the fact that the blower housing hits the coil once you space a coil out like that, they said that they intended to send us more spacers for the blower housing as well. So we're showing here where the blower housing cannot make contact with the block right there. So once these flywheels become available for purchase, it sounds like you're going to get 6 spacers, 2 for the coil and 4 for the blower housing, and then you'll get 2 bolts as well, 2 longer bolts to bolt the coil onto the engine. And now we move on to putting the blower housing on. We didn't get any spacers for the blower housing, and we didn't have any handy, so we just used some M6 flat washers. I believe we used 3 flat washers on each bolt. And there you can see the flat washers that we use to space the blower housing away from the block to get the clearance that we needed from the coil. Now it's time for us to set the valve lash. There are a lot of videos on doing this, so we're just going to go over it quickly. But you have 2 nuts on the rockers there. You have the adjustment nut, and then you have a jam nut. And so we loosen up both of those nuts. Right now we're sliding our push rods in. You want to make sure that you get the push rods on top of the lifters. It's kind of hard to see in there, but if they're not on top of the lifters, you're not going to see the rocker arms move like that. So we're just testing right here to make sure that we do have the push rods on top of the lifters. And then we put a screwdriver down in the spark plug hole on top of the piston. With our left hand, we're moving the crank back and forth, and we're just bringing the piston up to the very top. It's kind of hard to see the piston just looking down inside the spark plug hole, so that's why we use the screwdriver. It makes it a little bit easier to see when the piston's at the very top. And so we use our feeler gauge. We set the lash to 4 thousandths, and so we run the feeler gauge in there between the rocker arm and the top of the valve, and then we use the adjuster nut to set that lash at the 4 thousandths setting, and then we use the jam nut to tighten the adjuster so it doesn't move. And then of course we have to double check and make sure it's set at 4 thousandths. Without fail, once you think you have it at 4 thousandths and then you tighten the jam nut and then you go to check it and it's always tighter, it always gets tighter. So we find ourselves making it a little bit looser than 4 thousandths and then tightening down that jam nut. We just want a little resistance on our feeler gauge. We don't want to force the feeler gauge in there, and then obviously we don't want any slop either. So we're going to cycle the engine over a few times before we do our final check. And what we're going to do is we're going to set the piston at top dead center on the compression stroke. So there you can see the intake valve close, and then we bring the piston up to the top, and that will be top dead center on the compression stroke. And this is where we'll do our last check to make sure the lash is set at 4 thousandths. And that's it. Now you can reassemble the rest of the engine. We hope you found this video helpful.